Okay, welcome everyone. If you hear the sound change a little bit, it's because I'm just recording directly into my iPad today rather than through the audio setup, which sounded like I got the stereo settings wrong on, so it only came through on your left ear. Let's try this again with Lesson 11, Climate Change and Solar Beer. I am going to ask you to return to your Meadows book and read Chapter 5, pages 111 through 141. It's going to be talking about systems traps. So basically, what are the ways that systems get trapped into a weird, funky space that feels like you can't get out of, right? Tied to that are going to be solutions to the traps in the reading. I'm going to therefore assign reading John Perlin's book on chapter 5 on horticulture. Okay, so you're going to see a quote down below in the lower left, diffraction patterns. So this is a theme, a common theme that I use to teach with. Instead of thinking about reflecting upon a topic or something else like that, because we have the full spectrum of optical phenomena to be thinking about as tools in thinking, we're using diffraction. Instead of reflection, I want you to use diffractive thinking. Diffraction patterns record the history of interaction, interference, reinforcement, difference. Donna Haraway is a major philosopher at the University of California, Santa Barbara, and it influenced another major philosopher, Karen Barad, on the interaction concept using diffraction patterns, using quantum physics and the like. And so you're seeing a diffraction pattern right here on the picture of the globe. That is actually a hologram, right? Where we've got a film on a credit card. Oftentimes, I'm assuming that this is like a credit card ID that contains a hologram. And the hologram is a reflective surface with all sorts of patterns across it that create interference, that reinforce certain wavelengths and cause other wavelengths to be dispersed. So like it is creating a semblance of three-dimensionality through diffraction. That's what a hologram is. Okay, so that's your reading. I think you want to pay attention to, this says reread, but what you want to pay attention to is the Little Ice Age and how horticulture, how agriculture shifted from the 16th century through the 19th century. And you're going to see a lot of things that are tied to solar conditions, that are tied to volcanic eruptions that interfere with light, that then interfere with plant growth. So we're really finding that differences in conditions of the sky, in the chemistry of the sky, differences in the way that humans are interactively co-creating our environment have been happening for a long time. And those differences are going to emerge in the Little Ice Age, and we're going to use that as a discussion tool today. Okay, let's move forward. So one of the things that you're learning in looking at John Perlin's book is that, John calls it Let It Shine, the 6,000-year story of solar energy, when in fact we're actually talking about 10,000 years of solar ecology, of solar as the story of society. The Neolithic Revolution was happening because of the advent of agriculture and architecture. So you find these kind of interfaces, and essentially solar has been happening everywhere for 10,000 years as a human environment interactive co-creation of design, of living styles, and it's really cool. And as we have been affected by the sun and our environment, we have in turn affected the environment that we are in. And one of the things in Perlin's reading that I want you to take a look at, you've already read about the Roman baths and windows and glass and how that allows energy, shortwave light, in, but traps convective air that's warm, and it also traps long-wave radiation into a room. You're going to see a similar type of development in Chapter 5 of Perlin, tied to the 1600s, 1700s. This would be the 17th century, which, if you watched John Greene's video on the Little Ice Age, the 17th century was the bad one. Really, really rough times all around in Europe and effectively around the planet. So fruit walls. Pay attention to what fruit walls are. They are wonderfully designed solar energy conversion systems where the wall itself absorbs the sun, it heats up, and that long wave radiation that comes off of the stone or the brick is what allows the fruit to ripen. So it's not light as shortwave light that's making the difference. It's the long wave light coming out of the walls that maintains the fruit. One thing that will become very apparent as you go along through your studies of solar energy, through your continued studies of solar as light matter, interactive becomings, is that solar, shortwave light, is always assumed to be all about photosynthesis, but in fact, it is an extremely strong optocaloric driver. Shortwave light drives thermal exchanges, radiative thermal exchanges. Long-wave light, which we do not see, also drives optocaloric exchanges. We're oftentimes usually trapped by our eyes. And then on top of that, because we have studied photosynthesis in so many of our science classes, we assume that plants need maximal amounts of light in order to produce photosynthesis. Whereas, in fact, they don't. They need some light, but much of the light is going to thermally regulating a plant or the fruiting body of a plant. And a lot of light, say in the UV range, is going into converting the sugars and the different chemicals inside of the fruits into unusual and tasty materials that animals, and including humans, will eat. Okay, and so we have photovoltaics that reemerges in the 1950s, and we move on from here. So let's get to talking about beer. It is 9:25 in the morning, and I am talking about beer with you. So when I wanted to bring up is brewing history, because effectively brewing as a fermentation process to make a weakly alcoholic beverage is a way to purify a liquid so that you don't have bacteria in it. So basically, if you ferment, you create a colony that excludes pathogenic types of organisms from getting into your water stream. So you have a lot of kind of humorous stories about how beer saved civilization several times. And it is tied to the fact that brewing of fruit, honey, grains will all be tied to higher nutrients intake through drinking, to the point where it was called liquid bread beer, and it's really a socially defined structure as well. So you've got this before Common Era timeline that I drew from the web, and Common Era. So if we go to the before Common Era, right, this is BCE, you have to look at this and say, who is doing the brewing? Women are doing the brewing. So if we were to broadly define different tasks in gendered manners, what you would tend to find in societies is that brewing was associated with practices of women. And you don't, and remember, the Little Ice Age started in around the 1500s or so, but volcanic eruptions happened around the 1200s to the 1400s that started to kind of precipitate a major cooling effect, a global cooling effect. And what you do find is that you have an overlap of the decline of women brewing and frankly losing power within societal structures, and an increase of stories of witches, of persecution of people who have who are healthcare folks, who take care of the societies as being people with magical powers. And this is bizarre because it's all tied to a period of global cooling that greatly disturbed weather patterns. So the climate regimes, which are seasonal weather patterns, fingerprints of seasons, it would be climate regimes, right? They are weather patterns. They are not climate. It's a misnomer, but so the climate regimes are changing because of a global shift in climate, and you have food shortages, and you have in Europe you have very wet weather, and that makes crops rot. In West Africa you have droughts, and you have major social upheaval happening that is oftentimes looked at as linked to the social destabilization that went on and became the horrific mid-Atlantic slave trade. So a lot of these things are linked together, and I think I like the Brian Greene story on that because, one, it's condensed into a very short period of time, but two, it shows somebody who's not a solar person, who's looking at it from a historical perspective and the integration of science and history, and showing you that there's just so much connectivity throughout our experiences with climate change already. So you see in 1115, there was a German abbess. So a German abbess, Hildegard von Bingen. Hildegard von Bingen, if you don't know, was effectively better than Leonardo da Vinci. This was a woman who wrote music, brewed beer, wrote poetry and songs, and was everything the artist scientist that Leonardo would have been known for, and then some. She was managing an entire nunnery at the same time, and she had published so much information on how to use herbs and the like, and was actually the first person to really describe in text the use of hops for preserving alcoholic beverages that we now know as beer or ale. Okay, so fast forward to the 1500s. Little Ice Age is in full effect, even though it's the good years. So there's a quote. You have witch trials. You have Germans that imposed the Reinheitsgebot, which, excuse my pronunciation, which is a beer purity law. You can only make beer from, I think it's wheat, hops, or barley, hops, and water. And a lot of that is because earlier brewing traditions were not hops-based. They were based on local formulas, and we'll talk about that in a moment. You see a transition to majority hops-based beer brewing because of all of the different uncertainties and upheaval of the Little Ice Age, of our last socially known climate change event, right? And finally, you get into the nasty times of the 17th century. That's the one where Brian Greene really says it was really horrible. You have a lot of men dying, and a lot of women are starting to manage businesses, or let's say households, if not that. But American married women are serving small beer and cider to their families for good health. And so you would be a kid having small beer, and that would be a healthy, daily, nutritious beverage for you. Okay, so little different times, right? But vastly different in terms of solar ecological conditions. Swap forward to today. I've got a picture here in the lower left of a woman brewing a millet-based beer in called chouk in Burkina Faso. That's in West Africa. Chouk is a fairly well-known beverage, known by other names, but a millet beer is very, very common and is thousands of years old, and it is a task that is associated with women. Switch over to the lower right, and you have Peru making chicha. And chicha is a corn-based beer, but there are just as many types of brewings using rice that are associated with the same type of process. In England, what you call ale, it was being brewed with local herbs. So ale is called ale not because of its special fermentation processes, although that does distinguish an ale from a lager, but an ale is distinct in that it's not originally designed with hops. It is designed with local herbs that preserve and flavor a brewed product. In the Netherlands, this would be called gruit. And so you still have gruits out there. And like the whole brewing world has a deeply, I would say, feminist history that we should be aware of and that we're only beginning to rediscover. And that hops in and of itself was a structure that was built to preserve these alcoholic beers to travel further distances in shipping, because in Europe you have an increase in shipping that is associated with an increase of trade that is also associated with an increase of wars and moving people, troops, across boundaries over long distances. Not to mention the advent of trade and commerce across continents that was enabled by the mid-Atlantic slave trade. Okay? Moving on. So if we tie back to lesson 10, the last materials that I was talking about, you're going to see that I have this discussion on what is a regime and a regime shift. All of that, you can go on back and take a look at it. But regimes, climate regimes that are encompassing mesoscale, microscale weather regimes, and that are encompassing ecological regimes, and that are encompassing cloud regimes, those are all patterns. And those patterns change over the course of decades. And sometimes there's a disruptive, persistent shift called a regime shift, where all of these patterns change at every level. And we're experiencing that now. And I'm describing the Little Ice Age to really kind of bring home the fact that what is happening now and what is to come will require you in your lives to do some major adaptation if you are to, say, replicate the Dutch miracle. Okay? And that Greene talks about in the Little Ice Age. I'd be happy to answer questions about that later. So in the power disruption of the Little Ice Age, women definitely got, women and what we would effectively know as trans people really got the short end of the stick. And so what you saw was an increase in the use of hops to preserve and to kind of take that, what would be a profitable space, away from women brewing. And not only to do that, to move it into, so you see like the Trappist brewing from the Cistercian monks, it becomes male-dominated. And at the same time, you get a propaganda developing that describes women who are brewers. This would be an alewife or a brewster, like specifically gendered titles, became known as witches, became known as disruptors of society, and there was a propaganda that is well documented in Europe, and we've got this Mother Louse image and the pointed hat, that's a part of an alewife or a brewster's garb going out into a town center. The broom, a broom or something to stir the wort, is what you're seeing in the lower right. All of those things: the hat, the cauldron, the broom, the cat. A cat is there to keep the mice from eating the grain, so that you can keep brewing. So all of this tied together was the connection between witches. Thank you, October, for being here, and brewing. And that there had been a strong propaganda that set up that was tied to the Little Ice Age, tied to climate change, tied to lighting conditions and crops, and it was targeting the people who were thought to have power over the weather, which is not true, but interestingly enough, there's this deep solar connection with beer. So what I say on this is a lot of solar stuff is not rocket science. And then I once had a student who was in one of our engineering programs say, yeah, it's not rocket science, it's quantum field theory, meaning that it's actually much harder than rocket science. But the idea here in diffraction is that you find out that if you obscure that central light, that center beam that we think of in diffraction, and we start looking at the diffraction peaks and troughs in the margins, we're going to see a lot more patterns. We're going to make it easier to make diffractive thinking, to find out what can be measured and what matters in engineering design, in planning and stuff like that. And we can be prepared to be the next generation's Dutch miracle, to be the designers, the creators of the coming changing societal norms. And they are coming. The question is, are you going to be a part of that and to build an equitable and just space for people in their changing environments? Or are you going to allow fear and propaganda and power imbalances to build, because it just doesn't seem like it's your time? I am telling you now, it is your time. You belong here. You should be engaging in diffractive thinking. And I think that's the main point I wanted to get across. I'm going to jump to the next few slides just to double check. Oh yeah, so this was kind of an example of a diffractive thinking. We often think that we're in a scarce society. Economics really frames everything in terms of a scarcity mentality, like there's just not enough stuff for people. If you are from the United States, if you are living in the United States, you know we are not scarce on anything. And so thinking diffractively, we would actually look at how do we look at the slack in our system, and how do we not look at efficiency, which is a scarcity mindset, but look at effectiveness, which is a slack mindset. What is effective? What actually would enact change that would support your community where you live? And so there is an interesting point here. I've got this diagramming of light where you see a laser light that is shining out. It's an emitter, so it's a diagramming light, and I have a diagramming tool for diffraction. And that diagramming tool for diffraction is basically saying that light, when diffractive thinking and diffractive co-creation of solutions in engineering are developed, you actually get different ideas about weather and how weather and time and locale are put together. And there's actually language, Greek language, Romantic languages, where the right time is different than the celestial sky time. And both time words are tied to things like weather. So you have kairos and ta meteora. Again, my pronunciation is horrible. That are also tied to ideas like the right time for action, and whereas celestial sky time would be like your watch time, your clock time. So météo and le temps in French, they're all over the place, okay? So the idea here is that patterns tied to effectiveness are going to be necessary as we move forward. Why does this matter to solar ecology? Because solar ecology is all about making a difference that matters to the people around us. We are tied to engineering. We are tied to our powerful systems of influence coming out of colleges. Man, do we have influence? I need you to consider engineering as an entangled process where you, the engineers, are all tied up and tangled together with the stakeholders that you're going to engage in a solar project design process, with the locale, the time and space that you're engaged with those stakeholders. What we're going to be moving towards is that the locale itself, the place, time of where a solar project, be it agriculture, be it photovoltaics, be it architecture, where that is, the locale actually becomes a stakeholder, somebody that you want to consider the voice of and that you will be entangled with in the design process. And we will continue later talking about what do we mean by entangled engineering and how that might be different from traditional colonial engineering processes that will be called 1, 2, 3 engineering in this class. Okay, so I'm going to stop there. I'm going to share this video with you, and shortly I will be jumping onto Zoom to see if anybody has any chats for our Friday Friday exhale. There we go. Have a great day, everyone. Bye-bye.